Hi everyone! Today I will show you the simplest way of recovering copper from precious metal refining wastes. This is not a tutorial, do not repeat anything shown in the video. Using acids to extract precious metals from e-waste, jewelry or any other source where copper is also present will sooner or later result in you having a large volume of copper-containing acidic waste. This waste has to be properly disposed of, but not before squeezing as much monetary value from it as possible. Copper, while not precious metal, is still valuable, as evident by all the quote-unquote people stealing it from job sites. Enough social commentary, let's get to the chemistry. Easiest way to turn copper salts to metal is by reducing them with a more reactive metal that is lower on the electronegativity scale. Zinc, aluminium, cobalt, tin, basically anything higher on the reactivity series will work, but iron is the most cost effective. As for how you carry out the reduction, you simply submerge the pieces of iron scrap into the copper salt solution and wait until all the copper deposits on the dissolving iron, adding more of it if necessary. Depending on the metal you're using and the cations present in the solution, other metals will also start to cement out. This can be everything from tin, nickel to gold and silver if you somehow messed up and they got into your waste solution. To speed up the reaction, you can knock off the thick layer of metal dendrites that builds upon the iron surface, exposing fresh metal. If left undisturbed, crystals can grow quite large. Here is 1 hour time lapse of the reaction. As you can see, copper flakes off pretty easily. And here is how much copper deposited overnight. After the reaction was finished, I decanted off most of the solution and filtered the produced copper powder. If you don't wash out all the iron salts, what you will get is such a blob of copper powder cemented together by iron oxide. To remove the iron oxide impurities, such copper needs to be smelted with a flux. I used borax. After loading my foamed concrete crucible with copper and with borax, I attempted to melt it with map gas torch. Didn't go the way I hoped it would, because I was running out of gas, and the pressure inside the canister was insufficient to deliver the amount of heat necessary to melt it. But at least I got some nice footage of the color of copper emission lines. While I failed to melt the copper powder, the pieces did sinter together, forming something certain Mesopotamian copper merchant would try to sell you as high-grade copper. Even if I were successful in melting it down and casting it into ingots, this is still low-quality dirty copper that contains many metallic impurities that need to be removed before it can be used. If possible, sell it as it is now. Refining it is energy intensive and expensive. In part 2, I will show you how this is done on an industrial scale. Now, to the few of you who are still watching, I will tell how I grew those copper dendrites on filter paper. I put the paper into a shallow dish containing a small volume of copper sulfate solution, and then I placed a piece of zinc on the top of the paper. After waiting a few hours, I removed the zinc and turned the paper over to see the crystals that grew on the bottom side. Thank you for watching, like, subscribe, and see you next week.